All right, so I think this is recording. Let's take a look here. We've got a polynomial function f, and we want to find the zeros of this function. So first we look to see if there's any greatest common factor, and there is. And x is common. All right, so now we want to work with this polynomial function. It is in standard form, but it is missing a power. So let's think of this as x to the fourth 0x cubed minus 6x squared minus 8x minus 3. All right, so let's create a list of possible zeros. Our factors of the constant term are just factors of 3. Factors of the leading coefficient, just 1. So that means our list of possible, and that's the key word, possible, rational zeros. Doesn't tell us anything if any of these zeros are irrational numbers, like the square root of 2. The factors of the constant term are your possible numerators, and for the leading coefficient, the denominator. So that means that we just have these 4 values to check. All right, so remember we're working with this reduced polynomial function, and we need a 0 in there as a placeholder for that missing power. So I'm just going to go through this list to see if I can find a 0 remainder. Then I'll know that that value is a 0. And positive 1 is not going to give us a 0. Let's try negative 1. And it does. So since this was x to the fourth, this is x cubed, so we still have to keep going. We still need to find more zeros before we try to look at our x method or anything. So it could be that negative 1 might have a multiplicity greater than 1. So let's just check and see if by chance we get lucky and find another 0. Maybe it is, maybe it's not. But it looks like it is. All right, so with 3 terms there, that's a quadratic. So let's write down what we have. Initially, we had a 5th degree polynomial. We factored out an x. Now, by generating this list And checking that list, we found that -1 was a 0. So in factored form, that means x plus 1 is. And in fact, -1 has a multiplicity of at least 2. Could be that it's even more than that. We'll have to wait and see. Let's look at x squared minus 2x minus 3. So it looks like that can factor. So we could have just kept going in the list and found the remaining factors. So this guy factors to x minus 3 times x plus 1. And we can combine our x plus 1 factors. We have a total of 3 of those. And then we have an x minus 3 also. So we've got 1 plus 3 is 4, plus 1 is 5. The original polynomial function was of degree 5. So we know we've factored it as far as we can go. The zeros of this function, x equals 0, x equals -1, and x equals 3. If we wanted, we could continue and write the multiplicities and describe how the graph intersects the x-axis, but it's not asking us to do that for this. It's just simply wanting to find the real zeros, because that's the more difficult part. It's pretty easy to recognize that all of these are odd multiplicities, and all of them would cross over the x-axis. All right, so I hope that helps, and I'll talk to you later. Bye.